You open your eyes, slowly at first. The sky above is unlike any you have ever seen. Washed in hues of deep crimson and burnt orange, the light muted, softened. Instead of the familiar, brilliant blue sky streaked with white clouds, you see a vast expanse tinged with warm reds, as if the atmosphere itself has been dipped in rust. The air you breathe is cooler and thinner than Earth's. It carries an unfamiliar scent, perhaps metallic or earthy in a way that reminds you of dry autumn leaves. Your body feels the slight tug of gravity beneath your feet, similar yet subtly different from home. You realize you are standing on a world far beyond Earth. Welcome to Kepler-186f. This planet orbits a distant red dwarf star, located nearly 580 light-years away in the constellation Cygnus. It was one of the first Earth-sized planets found in its star's habitable zone, a rare celestial sweet spot where temperatures might allow liquid water to flow on its surface. But what does this mean for a traveler like you, stepping out into its alien landscape? What sensations, sights, and dangers await? As you take your first cautious steps, you begin to understand just how different, and yet strangely familiar, this world truly is. Look upward. The star that gives this planet light and warmth is nothing like our sun Kepler. 186 is a red dwarf, smaller, cooler, and less luminous. Its glow is soft and subdued, emitting mainly red and infrared wavelengths rather than bright yellow-white light. Standing here beneath its faint glow, you notice the shadows it casts. They are long, lean, tinged with red, stretching farther than those on Earth. The sky itself seems to shimmer with a muted palette. Deep reds fade to bronze near the horizon, blending into an inky twilight at night. Because the star is cooler, the light you see is gentler, almost comforting, but you also feel its limitations. The energy it delivers is about 1/3 of what Earth receives from the sun. This means warmth is scarce and precious, and the very cycle of day and night feels stretched. A single year here lasts about 130 Earth days, time flowing slower, inviting a different rhythm to life. The star is also more active than our sun. Red dwarfs are known for flares, sudden bursts of radiation and particles that can batter their planets. You might imagine, at times, the sky flashing briefly with energetic auroras, ribbons of color dancing far beyond what you know on Earth. You inhale, feeling the air fill your lungs. But what exactly are you breathing? We do not yet know if Kepler-186f holds a stable atmosphere, let alone its exact composition. It could be Earth-like, with nitrogen, oxygen, and trace gases that support life. Or it might be dominated by carbon dioxide, with thin, cold air barely able to trap heat. If the atmosphere is thick enough, it would act as a protective blanket, warming the planet's surface to temperatures where liquid water could pool. Without it, the surface would freeze in the cold vacuum of space. Imagine the sensation: the air cool, perhaps dry, with a metallic or mineral tang hinting at distant rocks or ice. Breathing might be a subtle effort, your body adjusting to slightly lower pressure. The sky overhead is a dusty rose during the day, shifting to a star-studded twilight that spills over into deep, velvety night. Clouds could drift lazily in the sky, colored faint red by the sun's spectrum, bringing occasional mist or rain. Or perhaps the atmosphere is thin and fragile, offering little protection from cosmic rays and solar flares. Radiation levels might spike unpredictably, forcing life to hide underground or in protective shelters. Beneath your feet, the ground feels solid and unyielding. The gravity here is close to Earth's, maybe about 1.1 to 1.2 times as strong. So your footsteps are steady but heavier, your muscles adjusting to the subtle pull. You gaze across the horizon. The terrain is rugged and wild, painted in shades of rust and crimson. The soil likely contains rich iron deposits, giving it a rusty hue that gleams faintly under the red sun. Jagged mountains rise like scars on the planet's surface, their peaks capped with ice or frost that glints at sunrise. Valleys snake between hills, carved long ago by flowing water, or perhaps volcanic lava, sculpting the land into mysterious shapes. Pools of liquid water shimmer quietly in lowlands, reflecting the faint red light, fringed with strange, dark vegetation. If life has evolved here, it might look utterly alien. Plants with dark, almost black leaves, absorbing every photon of red and infrared light. Creatures might be slow-moving and resilient, with eyes adapted to the dim light, capable of seeing in wavelengths invisible to humans. The landscape is eerily quiet. No familiar birdsong or rustling leaves, but perhaps the faint whisper of wind in rocky canyons or the distant rumble of tectonic activity hints at a world alive and dynamic. You feel the chill in the air. Without a substantial atmosphere, the temperature would plummet to freezing depths, around -85 degrees Celsius, a world cloaked in ice and dry frost. But if an atmosphere exists, greenhouse gases like carbon dioxide and methane could trap heat, raising temperatures near the equator above freezing, allowing liquid water to exist. In these regions, you might experience mild warmth during the day, punctuated by cool, freezing nights. Weather on Kepler-186f would likely be unlike anything on Earth. The red dwarf star's lower energy output means less solar heating, leading to weaker winds and slower weather patterns. Yet, storms could still brew, clouds forming from vapor in the atmosphere, rains falling softly or sometimes in fierce bursts. If the planet rotates slowly or is tidally locked, one side always facing the star, then weather would be dramatically different between the day and night sides. On the sunlit side, warmth and possible rain. On the dark side, freezing cold and endless night. Seasons, too, depend on the planet's tilt. A tilt like Earth's would mean slow-changing seasons over the 130-day orbit. Little tilt, and seasons would be faint or non-existent. The cycle of day and night here carries a profound difference. Dawn unfolds slowly, the horizon brightening with a faint reddish glow, spreading warmth and light like spilled wine. As the sun climbs higher, its light remains soft, never blazing, but consistently warm. The sky is a canvas of reds and oranges, with shadows long and tinted. Midday heat is gentle, less intense than Earth's, but still enough to feel alive beneath it. At dusk, the light fades in reverse, leaving a crimson twilight that deepens into a starry night. Without a bright moon or nearby planets lighting the sky, the stars shine fiercely, more brilliant and countless than the night skies you once knew. Here, the Milky Way is a dazzling river of stars. You might glimpse distant galaxies or neighboring exoplanets orbiting their stars. At night, the air chills, frost forming on rocks and plants. The silence is profound, broken only by the occasional sound of shifting ice or distant geological tremors. Could life have found a way here? Kepler-186f lies within the habitable zone, where liquid water is possible, an essential ingredient for life as we know it. If life exists, it may have evolved unique strategies to survive under a red dwarf's light. Plants might be dark-colored, designed to capture the abundant red and infrared light. Animals could be slow, energy efficient, hiding from flares and harsh nights. Perhaps microbial life thrives in underground caves or in shallow pools. Maybe alien ecosystems flourish in niches we cannot imagine. Or maybe this world is lifeless, a barren rock bathed in distant red light, awaiting the spark of life. Despite what we imagine, many questions remain unanswered. Does Kepler-186f have a thick atmosphere? Does it have a magnetic field shielding it from harsh stellar radiation? Is it tidally locked, facing perpetual day on one side and night on the other? Radiation from stellar flares could threaten life. Atmospheric loss might have stripped the planet over billions of years. Volcanic activity or lack thereof shapes its surface and climate. Explorers here face unknown risks, from intense radiation bursts to unpredictable weather to psychological isolation on a distant world with no rescue.